works. Okay, awesome. So, lightning talk. My name is Dalvin. I was a engineer at Stitch Fix about a year and a half ago. Well, I just left in January, and I worked as a backend engineer for the mobile app, which was in Rails. First software engineering gig out of college. So this is where I learned how a system operates and things of that nature. I currently work as an engineer at Dutchy, where I now work for their third-party integrations for the dispensary platform. So first thing, conformity is the jailer of freedom and the enemy of growth. Super tough quote, but it's kind of the why I picked it is because Rails wants you to follow and conform to its convention, but sometimes as a company, you have to make the decision to think outside the box and manipulate the language to your own use. So first off, let's build something cool. I heard Ruby and Rails is awesome. Every tech CEO. So Ruby and Rails is awesome. Many apps begin using the active record model. Basically, you click Rails S and you could deploy a website to Heroku in like 2 seconds. The community is super friendly. It could be the perfect way for you to get an MVP app out into the wild. And there's a ton of Rails developers globally. So you could just throw anybody on a project and they could take it to the next level. This is a bit of what literally clicking Rails S or Rails new app will generate for you. The Rails, when you click that command, it'll generate like 20 folders for you. It's a mess, it's a lot. But for somebody just learning how to code, it felt so easy because it created all that business logic for me, and I didn't have to think about it in that level of abstraction. So we have a person.create, and you're able to create a new class instantly. Oh my God, this app is huge. Let's break it up into pieces, every head of inch. So after you create this huge monolith of an app, engineering orgs decide to, let's break this up into microservices, right? And let's keep this in context. This was this decision that Stitch Fix took in their evolution as a company and where I'm getting this frame of mind up. So you'll have a microservice for payments. You'll have a microservice for shipping. You'll have a microservice just to manage your client data. And you'll have an API engineer like myself who would get that domain knowledge and become an expert of that domain. And then you won't have 20 people in your Git repository committing to the same line of code every 20 seconds if you break it up into these microservices. So you're able to iterate and take your own domain to the next level without stepping over somebody else's toes. So this is kind of like so off that first iteration of that screenshot I showed, this was kind of like how you would interact with a service. So I had that person object in the first screenshot, and now I'm essentially making an API call to this microservice using credentials that we create as an engineer org. And I pass in the person's name, age, date of birth, and then you'll create a new person object. So that's kind of like how you would interact with a microservice that, say, handle client data. What the heck is this JSON response? Every API engineer. So after you turn into a microservice, you're essentially taking in other people, you're taking in data, and then you're spitting out data. And there comes a point where contexts get lost, and every team, like you have new people like me hopping into the code base, trying to make changes. And I don't know what happened 2 months ago and why this data is like this. So a nil will pass by and it'll be in the Datadog errors, and now I gotta go splunking to figure out why it's there. So a microservice evolves, and there's this level of lore that as a new engineer, you lose out on, and you have to ask somebody that worked in a random chat to figure out why the system's like this instead of it being in the docs. So now you have to basically work with these multiple silos of teams and figure out service level objectives, talk about um, ask them why the API docs are like this, and basically uh, work to understand and make up pieces of the system that you don't have knowledge about. Just put some logs. We see that happen. We'll see what happens in a few days, every engineer. So, as I mentioned, um, our system now has evolved and we have a microservice. I, as a new engineer, don't know what the heck is going on. So I'm going to throw some logs into the system to see what happens. And that's kind of like, that's kind of like my job would now be try to like tighten this bolts of this new system and make sure that bad data doesn't come in. But as a system, we can't prevent that from happening. There's always going to be ways for somebody to use the system wrong, maybe through poor documentation or knowledge of not basically nobody has the intent unless they're a bad actor to interact with your system the wrong way. So there's always a way for bad data to come in. And this is kind of like a way, evolution of that service and why there's certain error handling patterns in our code base that you might not be familiar with. And then my point here is there's something as too much logging. Every log in my eye needs to have an end date. You want to work towards eliminating as much noise as possible, but we as engineers like to throw logs and forget about them, that your alerts channel end up looking like the Bible, in the sense that you don't know what is happening. Well, I don't know. That example isn't that great, but it's so long and you have to basically go through. No, it does make sense because you got to go through your chats, your Slack chats, to go back in history to see how somebody handled this issue in the past, and also you have to build context around what's going on. So too much logging might be too noisy, and that further adds, and especially as a new engineer coming in, you won't have that context and you're essentially lost. And then we reach to this point, I think we got this, some naive, optimistic engineer. So as I mentioned, we have too much logs. So, okay, so first we have a monolith. We turned it into a service. Um, we turned it into a microservice. We threw logs in there to understand what's going on. And we also added error handling patterns to handle cases for things that we think we know and understand how to interact with other services. This domain model is essentially a way to give more understanding to what's coming in and out of our system as an engineer. This is something that a Stitch Fix engineer actually created, which is a Ruby gem, which helps you filter out your JSON response so that you essentially have better understanding of the data that's coming in and out. So instead of passing in like a giant JSON blob with nested data, you'd actually be able to give it kind of like object-oriented properties so that you know what your client, well, your consumer of your data is going to take, and be able to filter out the noise that you don't need from the JSON blob, giving you more understanding of your system in the long run. I know this is a lot, but this is essentially the person class that we saw from the last example. You add your own custom validation handling in the method below, which will essentially, it'll be like, okay, I have a nil, or the age is incorrect, I'll create my own error handling pattern for this object specifically. So you have a better understanding of what happens in a happy path, in a sad path. And so you're not creating random error handling formats. And then this is just essentially taking all that junk that we had in the previous slide and cleaning it up and hiding that all that business logic in a service object. So now our controllers that we're interacting with the service is clean, and all that messy validation logic is now in the back. So I say this all to like cap it off like this. APIs are glorified plumbers. Bear with me on this example. As an API engineer, your job is to make sure that crap doesn't get in your system, and there's a clear directions to consumers on how you want to interact with it. So whether the consumer is a hobbyist or somebody else from a cross-platform team, you want to be able to have API docs that are clear to understand. There's convention around how you want people to interact with your system. Your error handling is on point so that any new engineer could hop in and make changes. And also you have a standard pattern. So for error handling, so you're not just guessing what happens in the sad path. So as an API engineer, my job is to talk to, it's basically engineer the API in a way so that it's friendly for anybody that uses it. Oh crap, I went to the wrong side. I'm sorry. Ugh. So to end this off, the characteristics of a good API is that it's observable, being able to see what's going on and mitigate issues fast. You don't want your system to have like 2,000 log statements that aren't addressable and you're able to make changes to. You, your system must have integrity. You want to trust that the microservice that you're using or system that you're calling is going to give you the right data anytime you need it, and you don't want to question whether it's correct. Scalable. Your system must be scalable. Uh, you must be able to handle spikes in traffic, um, and that's kind of a vague term, but I need a hour talk about that. And then simplicity, being able to decouple your data models so that they could be easily updated and anybody on your team can make changes to how the format is, the data is formatted. Thank you so much for listening to my lightning talk. I know that was not lightning. That was more of like a tortoise, but I tried. Is there any questions?
Feel free to